Welcome to this explainer. Today, we are heading for the absolute edge of human comprehension. We're going to be exploring a fascinating concept that bridges the gap between the rigid rules of mathematics, the extreme physics of the cosmos, and the rapidly accelerating timeline of our own technological future. Now, it's a word you have probably heard thrown around in science fiction or maybe tech headlines, but today we're going to break down exactly what it means, why it actually matters, and why it represents the ultimate frontier of human knowledge.
So what happens when progress becomes exponential and our predictive capabilities completely break down? That is the central mystery we're unraveling today. I mean, think about it. As humans, we spend our entire lives relying on predictable rules. Gravity pulls things down. Math equations give us the exact same, reliable answers every single time. And technology generally progresses at a steady, understandable march. We rely on models to predict tomorrow based on today. But what we're exploring in this explainer is the exact point where all those models and all those rules we rely on simply stop working.
And that brings us to a single word, singularity. It isn't just one specific physical object. It is the exact point where our current mathematical models or our predictive capabilities completely and totally break down. And why do they break down? Because a value suddenly becomes infinite or progress becomes uncontrollably exponential. Whether we're looking up at the darkest corners of deep space or looking forward at the horizon of future tech, this single word represents the absolute limit of our current models. It's basically the boundary where the math just throws its hands up and screams, "I don't know what happens next."
Let's start with part 1, the mathematical singularity. I want you to think about a single, simple number, 0. To really understand a singularity, picture a very simple mathematical function, f of x equals 1 divided by x. Try to picture what happens to the result as your x gets smaller and smaller, approaching 0. If x is 0.1, the result is 10. If x is 0.01, the result is 100, right? As you get closer and closer to 0, the value of that function just shoots wildly upward. It gets larger and larger, rocketing toward infinity. But what happens when you hit 0 exactly? Well, you absolutely cannot divide by 0. It's a completely impossible action. Right at 0, the function is utterly broken. That exact point, where x equals 0, is the mathematical singularity for that function.
And you know, this illustrates a massive divide in the language of math. Standard mathematical models are what mathematicians call well-behaved. They give us predictable, stable answers. We use this well-behaved math to build massive suspension bridges, to fly airplanes, to map the stars. But when you hit a singularity, a given mathematical object becomes completely undefined. It fails to be well-behaved. It's a point where the underlying logic just snaps and the rules no longer apply.
Now let's scale things way up. Part 2, the gravitational singularity.
A gravitational singularity exists in the very dead center of a black hole. Imagine an entire massive star, literally millions of times heavier than our Earth, just collapsing in on itself at the end of its life. According to our astronomical models, all that matter is crushed down into a single point. But it gets so much weirder than that. At this specific point, the density is infinite and the physical volume is literally 0. And because of that infinite density, the curvature of space-time itself becomes infinite. The sheer scale of this phenomenon is just staggering. The very fabric of reality breaks down to the point where time itself effectively stops.
To really grasp the scientific dilemma here, let's look at general relativity. This is Einstein's masterpiece, our current, amazing understanding of physics that brilliantly explains gravity and the universe on a massive scale. But general relativity absolutely cannot describe what happens at a singularity. It completely fails. The math shoots to infinity, exactly like dividing by 0. Our greatest physical model is totally broken by this cosmic phenomenon. So to solve this, scientists are desperately searching for quantum gravity. This is the holy grail of physics right now. It's a theoretical bridge that researchers hope can finally connect the very large forces of gravity with the microscopic mechanics of the quantum world, so we can finally explain what happens inside that zero-volume point.
Which brings us back down to Earth. Part 3, the technological singularity. This is an existential concept intensely debated by computer scientists and philosophers today, the technological singularity. This is a hypothetical future point in time where technological growth becomes totally uncontrollable and totally irreversible. And let's be super clear here, we aren't just talking about getting slightly faster computers or better smartphone batteries. This concept is intimately linked to the creation of artificial superintelligence, or ASI. Just like gravity breaking down in the center of a black hole, this represents a theoretical threshold where human predictive capabilities completely and utterly fail. Let's walk through exactly how this happens. This is known as the intelligence explosion chain, and it perfectly visualizes how progress shifts from linear to terrifyingly exponential. Okay, step 1. Advanced AI is created by human engineers. It's incredibly smart, perhaps exactly as smart as a human. Then we hit step 2. That AI uses its vast intelligence to design an even more intelligent, upgraded version of itself, which inevitably leads right into step 3, a rapid cycle of self-improvement. The new, smarter AI builds an even better AI, which builds an even better AI, faster and faster, in a loop we just cannot control. The curve of progress goes completely vertical.
And that leads us to our final synthesis, part 4, facing the unpredictable. This brings us to a really stunning analogy drawn straight from our source material. In astrophysics, the event horizon of a black hole is a boundary that physically prevents us from seeing what happens inside the gravitational singularity. The gravity is so immense that not even light escapes to tell the tale to our telescopes. While the technological singularity acts in the exact same way for time in human history. The sheer speed, scale, and complexity of an intelligence explosion mean that human intelligence would simply be unable to comprehend or predict the world that follows. The creation of an artificial superintelligence literally acts as an event horizon for our future. We simply cannot see past it.
So this leaves us with a deeply provocative question I want you to take away from this explainer. If technological growth becomes uncontrollable, what does the incomprehensible world that follows actually look like? We know exactly what happens when math breaks down on a piece of paper. We can mathematically hypothesize what happens when gravity breaks down in the depths of space. But when the very limits of human foresight break down right here on Earth, driven by our own technological creations, what is waiting for us on the other side? It is absolutely the ultimate frontier. Thank you so much for joining me on this Explainer Focus Learners. Keep asking questions and keep exploring the edge of reality.